In this video we're going to be multiplying matrices. This process can be kind of daunting, kind of confusing. It can get complicated. It could be a lot of numbers all at one spot. So it's very important to stay organized when you're multiplying matrices. That way if you make a mistake, it's a lot easier to go back to the spot where you made the mistake rather than having to do the entire problem over. And the more matrices you multiply, the more you will understand how much of a pain doing the entire problem over again is. So let's try and stay organized. I'm going to give you some tips here. In order to multiply matrices, one thing you can do to kind of give yourself a clue as to what the outcome should look like is based on the size. Let's say that we had a 3 by 2 matrix. That would look something like 3 rows and 2 columns. There's 3 rows, here's 2 columns. And if I wanted to multiply that by another matrix, let's say this one is a 2 by 2. Let's use these examples here. So 2 rows, 2 columns, that's a 2 by 2. The first rule to multiply matrices is that this number, the number of columns in your first matrix, has to match the number of rows in your second matrix. Otherwise, the multiplication doesn't work, our process doesn't work, and it's not possible to do. So as long as those two numbers match up, we can go ahead and multiply, and the outcome is represented by the other two numbers. So the size of the product, or the outcome of our matrices after we multiply, will be this number. So 3 rows by 2 columns will be the size that we get when we actually are able to multiply these two matrices together. So again, check the number of columns and the number of rows. Make sure they're the same. If they are, then you know your outcome is going to be the size of the rows by columns over here. So your first step is to check number of rows in second matrix. And make sure they're equal to number of rows, number of columns in your first. Okay. And then the size will be your leftover numbers. So let's see if it works out. In order to multiply matrices, let's say that I have a simple one here. I have a row matrix and I have a column matrix. The row matrix is called A, column matrix is called B. The way that I actually multiply is that I take the first entry in my first row and I multiply it by the first entry in my first column. So we're really doing row by columns when we multiply. Row multiplied by columns. Kind of the same order as you would write the size of the matrix. Rows times columns. So first entry in the row times the first entry in the column. 3 times 2. If I have additional entries, I then do something weird. I add more products together. It seems strange that we're multiplying, but we're also adding at the same time. It's similar to distribution. So then we jump to our second entry in our first row and the second entry in our first column, and we multiply those two things together, so 0 times 0, and we're going to add that to our third entries, the product of our third entries, so -2 times -1. And what we do to simplify all of that Simplify your products, add it all together. So we have 6 plus 0 plus 2, and that all combines to 8. So even though we multiplied a matrix with 3 entries by another matrix with 3 entries, when we multiplied our 2 entries, we only got 1 entry as our product, or 1 entry as our outcome. And if you think back to what we were saying, what I was saying about the size, we got to say rows by columns. So this is a 1 row by 3 column matrix. This is a 3 rows by 1 column matrix. This number right here matches this number right here, so we were able to multiply them together, and our answer was the size of the other numbers, a 1 by 1 matrix. Alright, so that's the easiest that the multiplying gets, unless we add less entries. But I wanted to have a good amount of entries here just to show you what happens. So let's get more complicated. Let's see if we have bigger matrices and we try and multiply them together. You may see problems like find the product of A and B, and then you're given 2 matrices, one called A and one called B, and the idea is to multiply them together and get the product. So let's say that A is that matrix, B is this one. How do we multiply them together? Well, check the size first. So this is a 3 row by 2 column, so 3 by 2. This is a 2 row by 2 column, or 2 by 2 matrix. Compare these two numbers, are they equal? Yes, then we can go ahead and multiply, and we know our answer is going to be this size. We know our answer is going to be a 3 by 2 matrix. Let's see if that works out. First thing we got to do is multiply our first entry, first row, by the first entry, first column. -2 times -1. And we're going to keep going here. We want to add that to what's next in our row by what's next in our column here. So we move over to the 3's, the second entries, 3 and -2. And we're done with that row by column. So what we did is we did first row, first column, and got our entry as soon as we simplify for first row, first column. So what we need now is we need this spot over here, and that would be the spot referred to by first row, second column. So we know we need to multiply our first row by our second column to get the answer that goes in that spot. So we do -2, first entry in that row, over here times 3, first entry in the second column. And then we move over an entry. We do our second entries here, 3 and 4, and we're going to add those products. Okay, so now we know that we needed 2 columns, and we got our 2 columns right there. We know we need 3 rows, so we should have 2 more rows to go. Well, now, since we're looking at the answer to the spot that goes in the second row, first column, that tells us we need to multiply all of our entries in our second row, first column. So first entry would be 1 and -1 multiplied together. And we're going to add that to our second entries, -4 and -2. We're done with first or second row, first column. So then we move over to second row, second column. That means we multiply second row and second column together. So first entries 1 and 3, and add that to our second entry product, -4 and 4. Okay, done with the second row. Moving on to the third row, we want the spot filled right here. That's third row, first column. So we know we need to multiply third row, first column to get it. First entries would be 6 and -1. And we add that to our second entry product, 0 and -2. And then we move over to the next spot. This spot we would refer to as third row, second column, so we need to multiply third row, second column together. So first entry is 6 and 3. And add that to our second entry product, 0 and 4. And again, staying organized in this fashion will help tremendously, because at this step we want to simplify each of our little entries here. And if you kept it organized up to this point and you made a mistake, let's say that we put the wrong number in one of these spots, well, we'd easily be able to go back and check, well, okay, so what I need here are things from our first row, first column. Oh, I made a mistake, I didn't put the right number in. So I would put my right number in, and then I would easily be able to fix the spot in my answer. Whereas if you did not write this step and you were doing it all in your head, it would be a lot harder to correct and to find your mistake, and essentially you would just have to do the whole thing over, which would be a bummer. So let's simplify. -2 times -1, that's 2. 3 times -2 is -6, so 3 plus -6 is -4. Let's keep working on this column. 1 times -1 is -1. -4 times -2 is 8. So -1 plus 8 is 7. And keep going. 6 times -1, -6, plus 0 times anything is 0, so -6. So there's our first column complete. Let's move on to the second column. -2 times 3 is -6, plus 3 times 4 is 12. So add those together, we get a +6. We close up our brackets, we know we don't need any more room. 1 times 3 is 3, and -4 times 4 is -16. So combine those two, 3 and -16, we get -13. And last thing, 6 and 3 is 18, plus 0 times anything is 0, so we just get 18. So check your size. Did we end up with a 3 by 2 matrix? Well, we have 3 rows, 2 columns, so that is a 3 by 2. That checks off. And then other than that, you can double check with answers in a book or a friend and make sure that you got the same results or the same entries in your final matrix. So that's multiplying matrices. Hopefully you were able to follow those steps. Multiplying matrices is kind of complicated, but the more you do, the easier it becomes and the faster you'll get at it. So just remember to stay organized, and good luck multiplying matrices.